So in this video, I'm going to build up the radian measures for the unit circle. Now you'll notice that the degree measures are already listed out, and one of the things that you should notice is all of these degree measures are somehow related to 30, 45, or 60. So they're all built on 30, 60, 90, or 45, 45, 90 right triangles. So that's going to help us use what we know about those angles and those triangles to fill in the actual values for the X and Y values. For the radian measures, that's going to be these inside pieces. We're going to start with the easy one. All right. 0 degrees is 0 radians. 360 degrees is 2 pi radians. If I take 2 pi and I chop it in half, I would get pi radians. If I take pi radians and chop it in half, I get pi over 2 radians. Now, pi over 2 is the same thing as 90 degrees. And pi is 180. So if I take pi plus pi over 2, I get 3 pi over 2. Those are the 4 major places on the axes. So 0 or 2 pi is the same location, because doing a full 360 or a full 2 pi radians is 1 revolution and puts you right back to where you started from. Pi over 2 is 90. Pi is 180, and 3 pi over 2 is 270 degrees. Now, how do I find the rest of them? Well, let's start with the 45s. If I take a 90-degree angle and I chop it in half, that's going to get me my 45-degree angle. So half of pi over 2 is pi over 4. Now, to find the other values, so pi over 4 here, if I then add, I'll add pi over 4. So this would be 2 pi over 4, which would just reduce to pi over 2. If I go to 135, this would be 3 pi over 4. And basically what I'm doing is just counting it out. If I go to 180, that would be 4 pi over 4. 225 is 5 pi over 4. 6 pi over 4 is 3 pi over 2. That would reduce. And the last one is going to be 7 pi over 4 for 315. And if you want to prove it to yourself that you got all the way around, the 360 would be 8 pi over 4, which should look familiar because it's something I use with the coterminal angles as well. So those are the 45 reference angles. So notice that all of them have a denominator of 4. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4 all have a reference angle of 45 degrees. They are all 45 degrees away from the x-axis. All right, so those are going to be important as we get into other things in this unit. The ones that are kind of messy are the 30s and the 60s. So let's start with the 30s. If I look at the 90 and I want to get to 30, I had to do 1/3 of 90. So if the 90-degree angle was pi over 2 and I need to do 1/3 of that, just multiplying by 1/3, that turns into pi over 6. So 30-degree angle is pi over 6. Now what I can do is literally count out all of the 30-degree angles, which in this case is everything that ends with a 0, and figure out what the ones that are missing. So this is pi over 6. The next angle, which would be the 60 degrees, would be, hold on a second, let me get the right thing in there, would be 2 pi over 6, but that reduces to pi over 3. Then I can count out 3 pi over 6. Oh, hold on. Wrong place. 3 pi over 6. 3 over 6 is a half, so that's the 90. Then I've got 4 pi over 6. Well, 4 over 6 would be 2 pi over 3. How about 5 pi over 6? That can't reduce, so I'm just going to leave it as that. 6 pi over 6 is already reduced to pi. Hold on, I put the wrong thing there in the denominator. That's over 6. Let's see, 7 pi over 6 is 210. So 7 pi over 6. 8 pi over 6 is 4 pi over 3. 9 pi over 6 reduces to 3 pi over 2. 10 pi over 6. So how about 5 pi over 3? And last but not least would be 11 pi over 6. So those are the radian measures associated with the unit circle. Now, a couple things. I mentioned this with all of the 45s. So we have a denominator of 4, denominator of 4, denominator of 4, denominator of 4. Those all have a reference of pi over 4 or 45 degrees. Everything with a denominator of 6, so pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6 are all 30 degrees away, or pi over 6 degrees radians away from an x-axis. So those would all have a reference angle of 30 degrees or pi over 6. Anything with a denominator of 3, so pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3, all have a reference to the 60 degree angle or pi over 3. So everything in the unit circle angle-wise is somehow related to 30, 60s, 90s, or 45, 45, 90s. I'm going to cut the video here, and separately I'm going to set up the exteriors with all of the angle measure, or not the angle measures, but the actual coordinates for the unit circle.